All right, Audrey, just so I can get this set up on my paper, are you going to use the a squared plus b squared equals c squared, or are you going to use the modified formula that we figured out? The modified, okay, I'll write that down first. So the leg that we're looking at here, right, is half x. So leg equals so then what do I fill in under the square root, Audrey? Squared, right? So then what was 15 squared? Yeah, that's a fun one. 225 minus 12 squared? 144. Again, guys, use your calculator, just make things go faster, too. I know you could do the subtraction in your head, but I'm certain that in a calculator, you'll get the right answer just as fast. I can't guarantee it'll be any faster, but I guarantee it's right. If we type in 225 minus 144, we got, I don't know. I'm going to trust you, sure. 81. I did not type it in a calculator. That's why I'm looking at you guys. Do I go ahead and double that 81? No. The order is what's going to trip you up here. I have to do the square root over here before I can do the work on both sides. Now, I could do a times 2 out here and put a times 2 in front of this, but I don't need to yet. What is square root of 81? 9. So I'm going to get that half x equals 9 unless I do the doubling, which when we then do the doubling, what do we get? X is 18. So this bottom leg is 9, but the entire base of it is 18 because both of those would be 9. Questions? Go on. Second of the square button. Talking about second entry, grabbing the previous value. So guys, remember this button, the x root is not the square root. This button is your square root. So if you didn't know what square root of 81 is, we'd hit second, then this button. It will plug in the square root symbol, then we type in what we want under the square root, and then we hit enter.
Right, but like, what if we have like any random number, and then we do...
You want to do the square root
that,
of the answer that you got?
You do that. Can you do another thing after it? Like, how do you go back down to when you type in, it starts typing up in the...
What Logan's asking about is if I wanted to do like 3 squared plus 4 squared. So 3 squared plus, if you get stuck up in the power, that's because you used the arrow. So if you did 3 arrow, then square it, you just have to hit the right arrow. This right arrow drops you back down. So notice if I go left, I'm back into the problem that I was typing. But if I go right, it drops me back. Now I can hit plus. You're welcome. So, but if I hit just squared, the actual squared button, it moves me right along. Right? So that's the difference between what buttons do we use. And then it will go ahead and do the hard math for me. So, I'm always very scared to say this, but a shortcut, oh God, it feels bad coming out, like makes me want to throw up. A shortcut here is just do it all in your calculator. Oh, it hurts me to even say it. Do it all in your calculator. I can't say it. So, we know the hypotenuse is the biggest side. Right? So as long as when we look at this situation, we say, okay, the 10 is like our C, right? This 8 is A or B. We don't really care. It's one of the legs. So really, we know we're going to square this. we're going to square this. We're going to find the difference between their squares, and then we're going to take the root of it. So guys, literally what you could type into your calculator is that the a that we're looking for is the square root of 10 squared minus 8 squared. And if you want to be a little bit safer as we type it in, do 10 squared. I'm going to delete all this. 10 squared minus 8 squared. Then watch up here. Watch up here. Let's say this wasn't a nice number. Remember, we can do second square root, second. Wrong calculator. There it is. No, this. So second insert, second square root, second, this button down here that has A and S above it, that means it's going to plug in your previous answer. Okay, but don't get in that habit because that won't necessarily be true in every calculator. So know where the button is. So let's say I was doing something complicated. Like, this is slightly more complicated. 15 squared minus 12 squared. And then I want to take the square root of second, watch it. I come down here and I hit this answer button. It puts in A and S, but what that actually is the 81 that I had from up there. Now, you could also just type it in, right? Oh, wow, whoa. And now I can see it and be sure of what I'm doing. So, yes, to those of you sitting here saying, I don't need to write any of this down. I can just do it in my calculator. Yes, you're right, but you're going to make a mistake eventually. I would always write stuff down. Now, why do I say you're going to make a mistake eventually? Well, because stuff gets harder, right? Now, what are we looking for here? Oh, wait. Is that hypotenuse or leg that we're missing? For the first two. Ooh, careful. Eye of the beholder, right? Eye of the beholder. Let's do this one real quick to see how it's the same as the ones before, and then we'll look at this middle one and see how it's not the same as the ones before. So, hypotenuse is 5, other leg is 6. My other leg I'm missing, right? So, I'm just going to do 5 squared minus 6 squared, and then square root that. Oh, man. Trap door. I'm really glad that you guys didn't let me get away with that. Please do not fall in the trap of looking at this. Guys, here's the trap I just set for you. And I'll admit, yeah, I was kind of being a jerk and setting a trap. If I'm like, oh, I can do it all on my calculator. 5 squared minus 6 squared equals a negative. This should tell you you've done something wrong. Then if you try to square root it, it's gonna tell you you did something wrong. Do not fall in the trap door. You gotta notate that this leg is not 6, it is 3. This leg is not 6. The whole base is 6. The leg is 3. By the way, when I kept saying side's a bad word, edge or leg or hypotenuse, right? Give it a better name. Edge tells us it's the edge of a shape. But leg is even more specific. Leg and hypotenuse are the parts of a triangle, right? Legs and hypotenuses. So, what we actually have is square root of 5 squared minus 3 squared. Wait a minute. Guys, we know what this is. With a hypotenuse of 3 and one leg of, or hypotenuse of 5 and a leg of 3, what's the other leg? I see it. Yell it. 4. It's 4. This is a 3, 4, 5 right triangle. Because when one leg is 3 and the hypotenuse is 5, the other leg has to be 4. There's no other option. Mathematically speaking, there's no other option. Okay, mathematically speaking, I guess we could throw some negatives around in there, but Logan? Did you use 6 instead? That would be the first thing that I would check. All right, over here, These look scary, but they're not. Ooh, now I have two hands up at the same time. Ooh, no, a lot more than two. I can't remember who I heard from last. Sophia? I mean, whatever. I don't really care who talks. I want to let anybody talk.
Can I explain how to do it?
Yeah, I might let both of you.
So,
You can go up there, too, if you want. No.
52 is actually the side. Like, it's not, you don't have to multiply or anything. You just use 52. But then
Careful. I know what you're trying to say, but you're saying it wrong.
I'm bad at, like,
Math is hard to explain. Charlotte? Yeah, what Sophia was trying to say is 52 is not your side edge. It's your c squared. So when we talk about squaring a square root, okay, we've got our c squared is 52. Because if c is radical 52, remember another name for square root is radical. If c is radical 52, then c squared is just 52. So again, we're saying the unknown leg x, okay, x will be equal to, but now c squared is 52. This is already squared. Minus what? Colin. Yeah, not 8, right? This is 4. So 4 squared. I'm going to go ahead and figure out what that is before I do it in my calculator because I'm afraid I'm going to make a mistake. So 4 squared is 16. That's what we're going to find the difference of. 36. Oh, well, we know the square root of that. What's the square root of 36? 6.
I know how to do it. It's just hard.
You were saying, like, I knew what you were saying, but you just said the wrong thing. Like, I knew what you meant.
Good afternoon, Phoenix. Please pardon the interruption. With today being the first day of spring sports tryouts, I just wanted to make sure everyone
Just
knows
listen.
how our swim shuttle works for today. After the end of 3B, if you're leaving for lacrosse, baseball, or softball tryouts, you'll exit at the door that the buses normally come to, but there is a clipboard on the doorway on the way out that you'll need to sign out. For anyone headed for Wolves, which is over at McCord, you'll be looking for bus 89. For anyone looking for the Cardinals, which is Working Way and Kilbourne Middle School, you'll be looking for bus 18. Also at the end of 3B, I'd like to please see Sarah Jacobson and Jamie Vance for just a moment. Thank you, and good luck to everyone trying out this week.
Woo-woo! I probably won't be allowed to come to sports events, but that's normally one of the parts of my job that I really like is spring sports. I ride my bicycle. No joke. I have a really nice bike, though. I ride my bike with my camera and stuff over to whatever sports, and I take pictures of you guys while you're playing. And often, no, it's all the yearbook staff at all the schools do the same thing. So sometimes we just share pictures, but there's always like teachers just taking pictures on the sidelines. But because I'm a teacher and I have a badge, I can go places your parents can't. So it's like I'm like right on the field. So I get sweet action. Yeah, I have like a press badge. Yeah. All right. The last one here is only different than all of the others because we're finding the hypotenuse. This is back to just the normal Pythagorean theorem. Except if you want a quote-unquote shortcut on that, our Pythagorean theorem is c squared equals a squared plus b squared. So we could just say c equals the square root of that sum. But guys, as soon as you see this triangle, your brain is like, wait, 3, 4? Oh, wait, no, it's not. It's not 4. It's not 4. Don't fall in the trap. It's not 4. This is 2. Guys, I know some of you already did this assignment in con, but like some of you are still falling in trap doors. That's why we're doing this together. Is the trap doors that you're falling into is like, oh, this is 5. No, it's not. Because this is not a 3, 4, it's a 3, 2. So 2 squared plus 3, oh, I can do this in my head. 2 squared is 4, 3 squared is 9, 4 and 9, 13. Yeah, guys, when I go to do this in my calculator, it's gonna be grosser than like broccoli.
Broccoli's delicious though.
Okay, with cheese. This is when I really, really like these calculators. Don't. I don't know how many don'ts that was, but do not give me the decimal answer of this number. I don't want it. It's gross. Give me radical 13. That is your answer. So C is radical 13. We do not write the decimal because it's not nice. Guys, I know sometimes I talk like other math teachers don't talk. It sucks to write so we don't do it. Right? Like, if I try to be accurate, the square root of 52 is a bad number to write. It's like, yeah, it's like 7 point blah, 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 like forever. But this is accurate. Radical 13 is accurate. But if I try to write it as a decimal, get out my fancy calculator because it will tell me the bad number. Square root of 13. It is 3.60555125, and it keeps going. Quit trying, I get it, Desmos is sweet, but every time I say something, you're like, yeah, but Desmos. All right, any questions from the front? Any questions from the front? Flip to the back. It's not bad. There's always a back. Come on, we live in a 3D world. It's whether or not the back has something on it. I don't know. In middle school, I think the fourth dimension is smell. You enter the smell dimension. All right, so guys, these problems, I've gotten 1 or 2 emails about it. These problems are, again, you can just straight up calculator work, or you can check, you can check your math in your brain. But to find out, are these going to be sides of a right triangle? What we do is we say, what is 5 squared plus 8 squared? Is it equal to 9 squared? No. Okay, this is a no then. No. Yeah, see? That exactly is what I'm talking about. You guys are making it too hard. So to check 6, 8, 10, and I know this one is, but I go 6 squared plus 8 squared. Is it equal to 10 squared? It is! Yay! Check the next 4 on your own. Check the 5, 7, radical 74, and the rest of these. Does C work out? Yes, because 5 squared plus 7 squared is 74. So C, the hypotenuse, would be the square root of it. So yes, C works here. Three squared is 9. Well, it's always got to be the biggest number. So assuming that, yes, it is the biggest, then yes, it is the hypotenuse. So as long as 6 is bigger than radical 27, but when I square and square, right, 3 squared is 9, but radical 27 squared becomes 27. What's 9 plus 27? 36, and the square root of that, oh, yay! A checks out. So does B. I was about to start calling on people. And so does C.
See if you know the square. If you know it's really broken, so it tells you to select the right number. Yeah, C works. Yeah, if you know that one works. Yeah.
So, Pythagoras. Whoa. Why? I don't understand why you guys react like you do sometimes. No, I just want to give you some backstory. So, Pythagoras, seriously guys, some of my, teaching through the years has turned into more of, I get to be a storyteller, and I like doing that. So, Pythagoras, and actually, guys, to tell you, like, this is true. I'm not making any of this up. Pythagoras had a group of intellectuals. You could say mathematicians, but I'm not sure that all of them were mathematicians. Some of them might have been, like, other branches. Probably mostly mathematicians. That were called the Pythagoreans. Right? Literally, it was like the group of Pythagoras' dudes. So if you're religious, think of, like, Jesus' disciples. Kind of similar. No joke. Like, Pythagoras had these guys that followed him around, did math with him. So they did this based off squares, right? A squared, B squared, C squared. What they were actually visualizing is if I had area related to these edge lengths, right? If we're talking about like fields or like a game or anything else that we're talking about area, and we literally took the edge and squared it out, and the edge and squared it out, and the edge and squared it out, the area of the two smaller squares will combine to equal the larger square. Yeah, way like thousands of years ago. Now, where this goes crazy, this works for any shape. Now, the Pythagoreans did not figure that out. So, technically, I'm smarter than Pythagoras, right? Because, no, I'm joking. But in college, we did spend a fair amount of time working through the proof of how this could actually work with circles. And my college math teacher literally made us little mugs that say better than Pythagoras. So I am better than Pythagoras as of spring 2011, which don't tell me how old you were in 2011. I don't want to know.
I love how you still have that with you.
What do you mean? I hope you guys appreciate when we give you things. Look, Dr. Jeff Smith was my professor back then. Love that dude. Yeah, and he would he would say, "Hey, call me Jeff. Like, don't call me Doctor. Don't call me Mr. Smith. Don't call me Jeff." He was a super cool dude. The class we took with him was how do you teach math? Not like let's learn more math, let's do hard, but how do you teach math to other people? One of the best classes I have ever taken, for real. So this, sorry, I really got lost because I'm thinking about Dr. Smith and. So I respect him enough that I normally just call him Dr. Smith. But this theorem, guys, if we haven't talked about it, theorem, remember, theorem means something that has been proven. So a lot of times people think theory and theorem has something, no. A theory is what somebody's thinking, like, oh, I think this might be true. A theorem has been proven. So when we talk about the Pythagorean theorem, it only became a theorem after people tested it. Right? Nobody could disprove it. It becomes a theorem. If we can disprove it, not a theorem anymore. Literally every textbook would have to be rewritten. If somebody disproves it, not a theorem. Nobody has in thousands of years. We're pretty safe. Logan? Because it can't be proven. Yep, you have to be able to prove it. Yeah, so sometimes there isn't the science available to prove or disprove, and it just stays a theory. That certain mathematicians and scientists have things that they've left that are still a theory because nobody can prove it yet. So like if you watch The Big Bang Theory, they are like scientists dealing with like string theory and the Super Hadron Collider and things like that. That has advanced us to be able to prove or disprove things that 100 years ago we just couldn't. We just could not prove or disprove. We could talk about, but we couldn't prove or disprove. This, the Pythagoreans took time to prove. They took time to test it and check it, and they said nobody can disprove it. So on the flip side, this lets us do some really cool, quick math. If this is a right triangle, this is 44, and that's 33, what's this? 11 units squared. Make sure you label it. And if we had a right triangle and you built a field off the hypotenuse of it, what would be the area? Oh, wait, well, first we just need to figure out, well, what's the hypotenuse here? What's 2 squared? What's 4 squared? 16 plus 4 is, so this is radical 20. So the field then would be, oh, yeah, because we square it. Hey, 20. 20 units squared. Yeah.
The thing that you were like demonstrating at the first, being 18 and 7. The actual question is that determine whether the triangle is a actual like a right triangle or not.
Oh, yeah. So, yeah, this is where I get too mixed up in what I'm saying. If this doesn't hold true, it's not a right triangle. So, yeah, the thing I forgot to say is, does 18 plus 7 equal 27? No. So since this is unequal, this is not right. Now, I'm not saying it's wrong, but it's not right. But, right. I didn't say you were wrong, but I said you were not right. Now, the last thing. I don't know if we have time. Oh, yeah, I do. Nah, I want you to take a moment on your own. How would we down here use the Pythagorean theorem on your own? Hand goes up immediately. On your own, take a moment to figure out how we apply the Pythagorean theorem. I'm only going to give you guys like 2 minutes, and then we'll do them together, and then we'll get out of here. Do you guys like having guided notes? Is it slightly easier? Yeah. I will keep it up. Especially as we get into geometry and you have to see shapes. That, yeah, there's no copying. Yeah, it saves time. I'm going to move my paper so I can write, so when we come back together, we'll double check your counting. Sometimes it's hard to count correctly on the boxes. Now, one of the things that Dr. Smith always said, and if I've already said this in this class, we'll get over it, because it's worth hearing a million times. Don't do nothing. Now, a better way to say that without using the double negative, do something. Do anything. Absolutely anything. Literally, just draw, doodle, sketch, but make it mathematical. So, since we're using right triangle theorems here, and when I look at my parallelogram, I don't see a right triangle, I ask myself, can I make one? Yes. So, if we go to make a right triangle, oh, wait. My bottom here is 8, but then when I made a right triangle up 8, is my bottom still 8? No. What bottom do I use there? Sophia? Yeah, so even though my entire base here is 8, be careful, I now realize I only actually want to use 6. Oh, wait. 6, 8. This is going to be 10. I can do the Pythagorean, but if I remember that this is what we call a Pythagorean triple, so remember, you might make this note for yourself. Pythagorean triple is any scaling of 3, 4, 5, or there's actually a couple more. Anyone know another Pythagorean triple? It's 5, 12, and 13 is another Pythagorean triple. 5, 12, 13. If you scale that up to like 10, 24, 26, like you can scale 5, 12, 13. Yeah, 500, 1200, 1300. Yeah, literally. Okay, hit us with it. Now you're talking for area. It cannot work for perimeter. Yeah, so he's absolutely right, but for area, we're going to talk about area next class. Since we're talking about perimeter here, I love what you're saying when we talk about area. But for perimeter, that'll mess us up, actually. Because if we make this a rectangle, we'll get an answer that's smaller than what it actually should be. So we would find out that this is actually 10, and then be able to find our perimeter by knowing, well, if it's a parallelogram, opposite sides are the same, 20 plus another 16, we would get 36. Over here, what kind of triangle is this?
3, 4, 5.
There you go. It's a 3, 4, 5. So I got 1 here, 5 there, 4 there, and a 1 there. Don't forget about this 1. That's the trapdoor they're trying to set. 20? Yeah.
Because it's 10 plus 10.
Units. Always put units. If you don't know what the label is, always just put units or units squared. And then flip this away where it goes in a binder, please. No shove and go. We've got to keep ourselves organized. We are going to have another binder check. I just don't know exactly when because of snow and stuff getting me all messed up. I don't know where to put it. There we go. Yeah, I love that strategy. Yep, turn them opposite directions.
Yeah, I have studies in one direction and the other one. And then that one was just being a hide everything binder.
I pretty much have one
Yeah.
binder per class, except one for global cultures. The science and connections one's shared because it's
Because they're always shared.